Whenever a client comes to us and asks like, how can he really leverage the ML? So to where we recommend and discuss two things with them is like, first, a client needs to think about creating a better services and product using ML. The second one is to look at the losses where his business operations are incurring and try to leverage ML to trim those down. In terms of business operation, we know that a lot of manual operations cost time and money. And after exploring the business processes for this client, we realized that the main pain area is the time lost in manual tagging and moving of the unstructured data. Operating on the unstructured data which is generated on the scale is very tedious and time consuming, and you require a lot of resources for that. In particular, when you have a large variety of the data, you need to think about how you're going to handle each and every data set, because when you have unstructured data, they can be vastly different from each other. Now, let's head over to the POC demonstration part and see what we have done for the solution part. All right, so over here, we have around 3 different use cases that POCs that you can do immediately with your unstructured data. What we are doing over here is we are leveraging the concept called transfer learning, where we are using the previously pre-trained model and tuning them on the small set of data that we have collected. Right? So everyone has a small set of unstructured data. I mean, for every business, there is some unstructured data just lying around, which can give you a great benefits if you start leveraging that. Now, for the fashion retail, it's mostly the catalog data. Now, it might sound trivial, but over the period of time, the catalog is not fixed entity. It changes a lot. It changes over the period of time, and it changes rapidly as the fashion moves forward. But how does your manual operation can coordinate with that? I believe it's difficult. So here, what we're trying to do is provide a solution for the exact same problem. Now, we want to derive a product categorization, say, like, so when you have a lot of unstructured data in, say, let's say images, and we want to categorize them. In this regards, this is a fashion data. So fashion images, right, for the models and the apparels that you have, the wares you have, and we want to categorize them. So we're going to randomly select few of them and pass it onto our system. Now, in terms of what this system and how it is made, there is in particularly a hierarchical machine learning operations happening at the back end for each and every categorization that is possible for us. There is a model working in sync with each other, and on the top hierarchy, we have a male and female products segmented from each other or segregated from each other. And the second hierarchy we have is what kind of wear it is. And the third is really what kind of product it is. So the results are pretty straightforward and visible to the eyes, is that we have a types and products rightly aggregated, segregated. All right, so let's just run one more thing and use the traditional and ethnic wear. All right, so we have the results now. Okay, so it has again succeeded in meeting our expectations by highlighting the female wears and the male, even though there is not much information about the body types. All right, so second part of this is a product attribution extraction. Now, when you have a lot of data and you quickly need to understand the data in terms of human interpretations, right? So you can leverage the machine learning by identifying and doing a supervised learning on the model. So we can pass on a particular image for product extraction. And what is doing is it's extracting the intricate details on the top of a hierarchical models and giving us what is a sleeve type, what could be the neck type, what it thinks probably or believes that this is a high probability is the neck type, and the product is sari, and the color, right? So let's just do that one more time. Okay, so interesting thing is it has figured out there is no sleeves types and there's no neck type from this image and has actually given us the colors. These are exotic colors, but we have tried to make this really accurate as possible by extracting the color schemes from the catalogs, different data sets that we have collected. Now, can we do it in a reverse order? What we have really seen that we can do from image, we can go from image to text attribute extraction, right? Can we go in the reverse order and actually retrieve the model, ask the model to retrieve the images from the particular attributes that we are presenting? So first of all, let's do some traditional way. Okay, so it's pretty accurate in this sense. For all of you who are not from India, so this is a traditional wear for the female. And let's just do some laser. All right, so it's a fact check, all male. Great. All right, so now you must be thinking like, how do we actually go about doing this for our organization? So there's an implementation process for each and every use case, which would be unique to each and every use case. After working through several clients, our trust has been reinforced in an industry standard practices of CRISP DSM, which is known as Cross Industry Standard Practices for the data mining. Now, what it does, it divides any data science projects into several phases. It also highlights the need for understanding the business domain by start asking questions of why before how. We need to have a conversation with the stakeholders about their pain areas and what they are actually trying to optimize, and how likely and what benefits are there for them when they start using the solution. Based on the qualitative information that we have derived and we have now a project scope, we start identifying what other data collections from the standard data sets that we can use from the client and to really start working on the project. Now, this could come in a form of a structured and unstructured data set collection. Then we move on to the data preparation cycle. What we're trying to do over here is to prepare the data which model can use in terms of features as well as the types of problems that data modeling can handle. Now, once we have the data modeling part, which is, by the way, the most iterative and experimental part of the things, we want to really test our experimental side and see whether it meets the reality and expectations and key performance indicators of the client. In this case, what we do is we deploy the solution and start working with the real data, which can be integrated with a pipeline of machine learning, which is commonly referred to as a machine learning ops or ML ops. And from that, we get the feedbacks from the stakeholders, from the first adopters, and running some statistical tests on the model and get the understanding of what actually needs to happen and the next directions of the future improvements from that.